Hello everyone, I'm Mr. 2X. I'm a math teacher here in Belgium. Hope you're doing fine. In this set of videos, we'll talk about inverse function. More precisely, in this one, we learn the purpose of those functions, why we need them. So before you get started, make sure to review all your basic trigonometry, all your basic function theory, and also how to compose functions. So, okay, let's get started. So you have here a right angle triangle. You know the length of AB, you know the length of AC, and you want to compute the value of alpha. Second question, you know the length of AB, you know the length of BC, and you want to know the length of the segment AC. After that, I want you to look after the similarity between those two problems, besides the fact that the triangles are right angled. So if you need some time, pause the video, try to find the solutions, and after that, try to find the similarity. The similarity is pretty unconscious actually, because you're doing it without knowing that there are inverse functions. Okay, for the first problem. You know we are working in a right angle triangle. You know the length of the opposite and the adjacent of alpha, so you know that you can use tangent to compute alpha. So tangent alpha is 4/7, and if you want to compute alpha, you need your calculator and compute tangent inverse of 4/7. And if you compute that, you'll find approximately 28 degrees, 7. For the second problem, you're in a right angle triangle. You know the length of AB and BC. You can use a Pythagoras theorem to compute AC. So in this problem, BC squared is the sum of AB squared and AC squared. So you need to isolate AC squared. So AC squared is BC squared minus AB squared. So you put the values of the length in this relation. So you know the value of AC squared, it's 33. And if you want to know AC, you take the square root of 33. And it gives approximately 5,7. So even if we have two right angle triangles, we needed to compute some different things. So what's similar to those two problems? It's not so easy to find it. And what's in red can help you to find what's similar. Did you find it? So what's similar in those two problems is the fact that to calculate your unknown, you needed to cancel a mathematical operation that was already acting on your unknown. Here, for the first one, the tangent was acting on your unknown alpha, and so you needed to cancel, in some sense, your tangent to find the value of alpha. So in this case, was the cancel operation of tangent is tangent inverse of, or what's also called arctangent. For the second one, here you knew the value of AC squared, but your unknown is AC, so you need to take the square root of AC squared to know AC. The square root cancels a square. So that's the similarity between those two problems. That's the purpose of inverse functions. So inverse functions are always relative to one specific function, okay? Like tangent, arctangent, square root, square. So the inverse function is always the operation that cancels to another one function, okay? So that's very important to know, and that's pretty why we need inverse functions. That's something that we always need. We always need to cancel something that's acting on some unknown. So if you find this video useful, thumbs up. If you think that this can help somebody to know, to understand what are inverse functions, you can transfer this video. And otherwise, I'll see you later. Bye.